we're going to learn how to draw the graph of such a thing. But in order to be able to draw the graph of such functions, there are two things that you have to be able to do. One is you have to be able to identify the highest order term, and the other one is to understand the behavior at the x-intercepts. So those two will be the ones that I'll try to explain. The first of all, what is the question? What is the highest order term? Now, to answer this question, one slow method would be to actually multiply this out to find out the highest order. Okay? And that's something that you probably don't want to do. So, so not recommended. Would be to do the following. You write down f of x as x plus 2 times x minus 1 times x minus 1 times x minus 1 times x minus 3 times x minus 3. So let's write it explicitly. Like cubic means you multiply it 3 times. Square means you multiply it twice, right? And if you multiply this one, it's going to be x squared plus x minus 2. If you multiply this one, it'll be x squared minus 2x plus 1. And if you multiply this one, it's going to be x squared minus 6x plus 9. Okay, you see where I'm going with this, right? Now, this is something that we shouldn't do. You see right away, it's going to be horrendous, right? What will we do next? We multiply x squared times x squared, x to the fourth. This would be not minus 2x. Oh, what's that? Cubed plus x squared, and then do this. That's x cubed. You already see that this is not what you want to do, right? Yeah. And you still have to multiply. After doing all this, you still have to multiply this. Yeah. However, we can still just imagine that we're doing the calculation and just follow the trail for the highest order term. By the way, you know what an order of a polynomial is, right? So this is order 2 because as I explained 2, order 3, order 3, order 4. Okay? So if you look at this part of the polynomial, this one is an order 4 polynomial because the highest order is x to the 4th. That's what order means. It's also known as degree. Okay? Degree or order. But okay, so how many of you were following so far? Okay, I'm not doing rocket science here. I'm just carefully just multiplying everything one by one, right? Yeah. But if you follow this much, then you can probably answer this question. If we patiently multiplied everything out, what will be the highest order term you're going to get? Yes? Yes, x to the 6, right? It will be x to the 6 and then some other things, blah, 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 blah. Yeah. I mean, there are some lower order terms, but the x to the 6 will be the highest order term because that's going to be created when x to the 4th and x squared gets multiplied. You agree? Right? Okay. So the answer to this question is x to the 6th, okay, is the highest order term. Now we're interested in the highest order term because knowing the highest order term allows you to determine the end behavior. So let me first draw a chart for you to see, and then explain what it means for the graph. Okay, so the end behavior chart. And by the way, you don't have to memorize this because we're going to find another way to figure this out. Okay, but so this is end behavior. And it's about the order, and this will be coefficient. Sorry if my writing is small. I wrote order and then coefficient, okay? Order and coefficient. If the order is even and the coefficient is positive, just like this one, right? What's the coefficient of x to the sixth power? 1, right? So it's positive. So it's this case. In that case, the end behavior of the graph is like this. Okay? If it was negative, then it would be that way. If the order was odd, if this, instead of 6, if it was like 5th power, 7th power, then the graph would be like that. And if it's negative, it would be like this. Those are the 4 possibilities of end behavior. They could be both going up, both going down, one going this way or going that way. Yeah, you can actually make a dance out of all the possible end behavior. Right? Okay. Now that we settled on the end behavior, once you identify the highest order term, then the next thing to do is to find the x-intercept. Q. Next question is, what are the x-intercepts? And last time we learned that for polynomials, x-intercepts are also known as zeros or roots. Okay? Yeah. So another way to phrase this question would be, what are the roots of this polynomial? Okay. And what is that? You set y as 0, right? So either x plus 2 is 0, in which case x would be negative 2, or x minus 1 is 0, in which case x would be 1, x minus 3 is 0, in which case x is 3. Yes?
Is there a recommended way to find the highest order? Because that says not recommended.
Oh, sorry. Yeah, I forgot about that. Okay, yeah. So, thank you. The recommended way to find the highest order is just use the simple fact that the highest order will be created when you multiply the highest order in each of the factors. Okay? So what's the higher order between these two? X, right? How about this one? X. This one is X. Okay, so all of them are X. So this would be X to the first power, and this would be X to the third power, and X squared, and that's going to be X to the sixth power. Yeah, just simply that. Okay, thank you. I forgot about that. Yeah. Okay. So coming back, I want to say that these roots have also multiplicities. Okay, so if you look at this, x plus 2 is the first power, so this has multiplicity of 1, and then what's the multiplicity of this one? 3, right? Because you see x minus 1 is repeated 3 times. So It's a 0 that appears 3 times. Okay. What's the multiplicity of this one? 2. Right. Okay, so these are the multiplicities. And now I'm ready to draw the graph. Okay. First of all, the end behavior is this, right? This is the end behavior. So what you do is put it like that, okay? So in the far end, far to the right or far to the left, the function will be increasing towards infinity, okay? All right. And then, oh, sorry, this should be, yeah. So you have -2, and you have 1, and then 3. So you have these 3 points, -2, 1, and 3 as the x-intercepts, okay? And multiplicities dictate how they interact with the x-axis. So let me write down the rules. So if the multiplicity is 1, okay, the behavior is that it crosses the x-axis. Now, if the multiplicity is 2 or 4 or 6 or any even number, then when it hits the x-axis, it bounces back. And then if the multiplicity is odd and 3 or more, that's because 1 is also odd, right? But 3 or more is similar to this, but it has slightly different behavior. So crosses the x-axis while almost, well, I'll just say almost horizontally. Almost horizontally. Okay? So it crosses almost horizontally. Let me explain by drawing the graph. You'll see what I mean by almost horizontally. All right? So let me start drawing the graph. Okay, so this is where the graph should come down from. Okay? And it has to get to -2 because at -2, we know that this function will be 0, right? If you plug in -2, every one of these are 0, so you get 0 times something, it's going to be 0, right? Yeah. But now look, what's the multiplicity of -2? 1, because it has power of 1, right? And what does it say? It just crosses over, so it just crosses over. Okay? It just passes through the x-axis, okay? All right, what's the next stop? It has to go to here. Now, since it's under, to go back to here, it has to turn back to go there, right? Okay. But what is the multiplicity at 1? It's 3. So it's an odd number with 3 or more. In that case, what happens is that it will be crossing over, but it momentarily becomes like horizontal and goes up. Okay? It does cross over, but it momentarily becomes horizontal, almost horizontally. And if you zoom it in, you'll see that it's not perfectly horizontal. It'll be like slightly above, but almost horizontally. Okay. And exactly at this point, it will be like at that moment, it will be like straight across, horizontal, but then it becomes horizontal and then goes up again. Okay, so that's what happens. All right. And then you still have to come back to hit 3, right? Because 3 is another stop. At 3, you have to have the x-intercept. And now what? Bounces back because the multiplicity is 2. It's an even number. So it bounces back and it goes up towards infinity. Yeah. So that's what it is. Okay, so these are the rules. Do you have any questions? All right. Now, once you accept that these are the rules, now let's talk a little bit more into why that happens. Now, last time we learned about the cubic curves, right? What were the cubic curves? Cubic curves are something that has order 3, right? If the highest order is 3, right, you call it a cubic curve. And cubic curves generally had this shape or this shape. Could be more like this. If A is positive, and if A was negative, it would look like this or this when A is negative. Okay, this is what we learned last time. Now, look at the end behavior of this one. What is it? This, right? Okay. What? Yeah. Look at the end behavior of this. Right? Okay, so positive is this one, negative is this one. You get that? Okay. And the order of this polynomial is odd, right? So for odd exponents, if the highest order term is an odd number, odd exponent, then you know that the end behavior should be either this or that, depending on whether the leading coefficient is positive or negative. Okay? So that immediately explains why this is true. Okay? So if you remember this example, which you have to know anyways, then you don't have to remember this as a separate rule. Okay? Now, what about even? What's the simplest even polynomial you can think of? What is it? What's the simplest even polynomial? Order 2, right? 2. What is that called? If you have order 2, what is that called? Quadratic, yes, quadratic function. Okay. So if you have a quadratic function, what's the shape of this polynomial? What's the shape of the graph? It's either this or that. It's a parabola, right? It's either opening up or down. Which one dictates that? Yeah, A. If A is positive, then it opens up, right? If A is negative, it's upside down parabola, okay? Again, you can see that the end behavior here is that, right? And behavior here is this, okay? This and this. That's true for the even case, right? So if you just know these two rules for the quadratic and the cubic, then for the general polynomial of higher degrees, this is kind of easy to remember. You don't want to memorize this, rather you want to memorize the specific cases, all right? Okay, that's what I want. First, think about the highest order term. Between these two, what is the highest order term? Negative 2x, right? Right. So it's going to be negative 2x. Between these two, what's the highest order term? X. And x to the second power, right? How about 5 and x? Which one? X. Now, if you multiply all of these, you get negative 2x to the 7th, right? 1 plus 2 plus 4. Yeah, 7th, right? Yeah. So that's the highest order term. Now, yes?
Last time when we were doing this, we added them or we multiplied them together. How come we're adding the exponents this time?
We are multiplying. If you multiply x squared times x to the 4th, it's what? X to the 6th power. We are multiplying, and this 6 is addition, right? Yeah, so if you multiply two numbers with the same base, exponents add up. See, if you do x squared times x to the fourth, what is that? That's x times x times x times x times x times x, right? How many x's did you multiply? You multiply x 6 times, right? Yeah. So what happened was that when we do the multiplication, we end up adding the exponents.
How did we end up with x6 last time? Highest order term.
Last time it was x times x cubed x squared, right? So 1 plus 3 plus 2 was x to the 6th. Yeah, it was addition of all of these. This somehow happened that if you multiply these numbers, you also get 6, but I really added them. Okay. Yeah. All right. Yeah. Okay. Sorry about that. Yeah, but we always add the exponents. Okay. Yeah. If you do multiplication, you add the exponents. All right. So we have that, and now the question is, what's the end behavior? Which one? Which one?
Starting.
It's this one. Okay. It's this one. All right. It's this one. Okay. Yeah. 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 All right. It's this one. You get it? Yeah. Yeah. Because it's like the cubic curve with the minus in exponent, right? So for the cubic curve, when you have a negative coefficient, it's like that, right? So it must be, end behavior must be that one. Agreed? All right. So you have the end behavior is this way and that way. Okay. Now let's try to find the zeros. So either 1 minus 2x is 0. When does this happen? Yeah, at 1/2, right? You add 2x both sides and divide by 2, it's 1/2, right? And over here, x plus 2 equals to 0, x equals to negative 2. This one, 5 plus x is equal to 0, you get x equals to negative 5. Let's write the multiplicities. What's the multiplicity here? 1, 2, 4. Right? You have 1, 2, and 4 as the multiplicities. Right? Because it's power 1, first power, second power, fourth power. Those are the multiplicities. Okay, so that allows us to draw the graph. Let's try this. You have negative 5 over here. Let's say this is negative 2. 1/2 is pretty close here. And the end behavior is that way and that way. So you have to start from up there. You have to start from up there. Comes down to hit negative 5. Okay, what happens? Bounces back or passes through? No. Fourth power. Even. Bounces back. Okay. Okay. Negative 2. Bounces back again. It's again even, right? So comes down, bounces back. Okay. At 1/2. It goes through because now it's a multiplicity 1, right? So it's like that. Okay? All right, so try this one on your own. Now, you don't have to always have x for your independent variable. Let's just use p, f of p. Okay, this time, let's say 1. Yeah, so hopefully this p instead of x is not going to mess it up. It's just if you have problem solving questions like this, just rewrite the question with x instead of p, and it should be fine. Yeah, right. Okay. All right. So if you were to actually multiply this out, what's going to happen? It would be 1 minus 2p times 1 minus 2p times 1 minus 2p, p plus 1 times 3 minus p times 3 minus p. And if you just did this much, what would it be? It's like 1 times 1 be 1 minus 2p, then negative 2p plus 4p squared. And then to this one, you have to multiply 1 minus 2p. So what's the highest order term? It will be, like this will be 1 minus 4p plus 4p squared. And when you multiply 1 minus 2p, it's going to be, what's the highest order term? This times this would be negative 8p cubed, right? Do you see that? Negative 8p cubed? All right. You're going to get negative 8p cubed just multiplying this much. Right? Right? Okay. Yeah. So that's no, I haven't multiplied the other ones yet. But here's my point, okay? If we had 30 minutes just to do this problem, then you would spend time just writing all the exponents. I FOIL this out, and it will take a long time. You probably don't want to do that, right? You don't have that much time, okay? So instead of that, what you're going to do is you're going to imagine what's going to happen if you did that, okay? Then how would you track down the highest order term? The highest order term will be produced when negative 2p, negative 2p, negative 2p, p, negative p, and negative p, all of these are multiplied. That's when you're going to get the highest order term. Don't you agree? Yeah. Right? So what you do is, instead of doing all the calculation, which will take 30 minutes, you're going to say it's negative 2p times negative 2p times negative 2p times p times negative p. That's the highest order term. What would this be? What's negative 2 times negative 2 times negative 2? Negative 8. Okay, and what's negative 1 times negative 1? Positive 1. So if you just multiply the coefficients, it's negative 8, right? Now, how many p's have you multiplied? Can you count it? How many p's? 6 of them. So p to what power? 6th power. Yeah. That's the highest order term. Okay.
Hold up.
Yeah.
You just broke your own rule. I got 2.
No, I haven't broken my own rule. Look, if you were doing the recommended way, this is what you would do. Look, we do between these two, the highest order is negative 2p, right? Take the 3rd power. Between these two, it's p. And then 3 and negative p, which one? Negative p squared, right? What's negative 2 to the 3rd power? Negative 8, right? And then p cubed times p. What's negative p squared? P squared, right? And therefore it's negative 8 p 6th power. So you get the same answer if you did it this way. Yeah. Yeah. Okay? Yes. It will be negative because you took the negative to the 3rd power, odd power. It will still be negative, right? Negative 1 squared will be positive 1. Okay? Yeah. Yes.
How come for the last example, when negative 2x first, x squared, and x to the 4th would be multiplied as negative 2x?
What was this one? X plus, what was it? X
Plus 2.
2 to the 2nd power? And then 5 plus x to the what? 4th power. So this was our previous example. In this case, negative 2x only has a 1st power, right? So there's negative 2x to the 1st power, x to the squared, x to the 4th. So in that case, it will be negative 2x to the 7th. But over here, you have negative 2 to the 3rd power, so it will be negative 8. You see the difference?
Yeah.
All right, good. All right, so either way, Either you would do it this way or that way. You get negative 8p cubed as the power, right? Okay. All right, so what's the end behavior? Down, both, yeah, both downwards, right? So end behavior is going to be that way. Okay, now let's find the zeros. 0 equals to 1 minus 2p cubed, p plus 1, 3 minus p squared, and you get 1 minus 2p equals to 0, which gives you, oh, we did this a moment ago, so it should be this. P plus 1 equals to 0 gives you p equals to negative 1. 3 minus p equals to 0 gives you p equals to 3. What's the multiplicities? This will be 3. This will be 1. This will be 2. Okay? Yeah, because it has exponent 2, exponent 1, exponent 3. All right, so now we can start drawing. The end behaviors are this way. What are the zeros? There's a 1/2 here, positive 3, and then there's a negative 2. Negative 1, sorry. Negative 1 is more like here. So those are the 3 places where the graph must pass through, okay? The graph should be touching either or going through these points. All right, since you're coming off of here, let's try to start from the bottom. Come up from here. Okay, we're stopping at negative 1. Okay, what happens at negative 1? It cuts through, but it's order 3, so almost horizontally and going back. Okay? So it's going to be like this, almost horizontal, and then increases. Okay, but abruptly has to fall back to 1/2. At 1/2, what happens? Oh no! What? Sorry, it's order 1. Sorry, I was looking at the wrong one. Yeah. It's order 1. Sorry, I was looking at this one. Okay. At negative 1, it's 1, so it passes through. At 1/2, it's 3. So what happens? Yeah. It touches like a horizontally and then comes back. Okay. All right. And then at 3, what happens? It has to go back to 3. It's square even, so it bounces back. So it will be like this. And if you did this correctly, it's going to match with the end behavior. Okay. So it'll be. That's the graph. Okay? All good?